All right, so with 1.7, we're trying to find the midpoint. And so I think to open this, we're saying, what is the like midpoint of a football game? And you're like, well, that's halftime. Well, and that means that half of the game is before it and half of the game is after it. It's kind of like it's the midpoint of a game. The midpoint of school might be during lunch. If it's kind of wherever in your day, half the days before or after, or the times before and after that point are going to be equal. And so, we can't really measure the midpoint of a segment because, or of a line because it kind of goes infinitely in both directions. So to find the middle of like an infinitely long shape doesn't make sense. However, we can, however, find the midpoint of a segment. Okay. And so because that has a finite length, and so therefore the midpoint would be at the halfway point. And so the midpoint is going to be the point that divides it directly in half. And so, if it is divided in half, then we would say that it forms two congruent segments. And so if you look at that symbol there and remember, hey, the equal sign with the little swirl over the top of it is going to be congruent. So if you have a midpoint, then that means it breaks the segment into two congruent pieces. So the side before it and after it are going to be equal in length to each other. Equidistant means an equal distance from a point. And so, with a circle, the value, the center, okay, it's going to be equal distant from every point on the circle. Excuse me. So if you look at this right here, this point is going to be an equal distant to this point here. So that length is the same as, say, the distance right here to every single point in the circle. So that's equal distance. It kind of sounds like you're saying the equal distance, but it's called equidistant. And so same with a midpoint. If you have a midpoint, it's equidistant or equal distances from each of those endpoints of that segment. And so vocabulary, that's what we're trying to grow this year. Another thing would be if you're trying to find the midpoint between two values, there's a formula. There are actually two. One is if it's just basically a line segment. No, I asked the class, just informally, like, what's the midpoint of most people's life? Well, it's going to be about 40. Why? Well, if you are born at 0 and the life expectancy might be perhaps 80, you add the beginning and the life expectancy together and divide by 2, and that's 40. And so the truth is that, a midpoint, and again, that's where people have their midlife crisis. So midpoint would be like the time before and after that point are equal in years or in days or whatever. And so just a visual, of like there are applications to this in real life. And so we speak of these words, but we're bringing them into math. We're going to talk about those in terms of like different shapes. So the midpoint between points A and B, a segment, to find them, you use this formula above. The formula above is going to be to find the midpoint, you take the values, the coordinates, and you add them together and divide by 2. So to find the midpoint of segment AB, you're going to take A plus B and divide by 2. So A plus B and divide by 2. Well, that's going to be equal to -3 plus 1 and divide by 2. If you add those values together, mind your signs, you get -2 and divide by 2 is going to give you -1. Go to -1, excuse me. And so do you see that the midpoint is going to be right at -1? And so it should be halfway between the two endpoints. It divides the segment into two congruent pieces. The midpoint between B and D, well, let's take the coordinate of B plus D and divide by 2. So B is -1, and you plus it to 6 and divide by 2. So that would be 5, and then divided by 2, which is going to give you 2.5. Can it be a decimal? Well, of course. 2.5 is the midpoint between those two values. So this would be the midpoint right here. So on a number line, even if you did like a timeline, you could take the 2 years and add them together and divide by 2. So you could find the middle between those values. Now on a coordinate plane, you've got X and Y. So you have to find the middle of the X's and the middle of the Y's. So the midpoint formula is basically you do the midpoint 2 times. And so look at this. So the midpoint, oh dear, I did not mean to do that. Let's erase this. Let's highlight it instead of scratch it out. So if you highlight this, you're going to get the x values added up and divided by 2. That'll find your middle of your x's. That's the x coordinate. And then to look at the y's, you add up the y values and divide by 2 to find the y coordinate of your ordered pair middle. Okay, so to find the coordinates of the midpoint, you're going to take these points. So this point right here is 1, 2. 1, 2. And this point right here is going to be 5, 5. So to find the x and the y, so to find the x, I'll get blue so you guys, so to get this blue, let's highlight it. To take the blue, you get 1 and 5, and you add them. You remember the distance for the minus, but in the midpoint, you take the x coordinates, you add them together and divide by 2. So that's 6 over 2, which is 3. And then to find the midpoint of the y coordinate values, you take the y values, which is going to be 2 plus 5. So these guys right here, this one right here, and this right here. 2 plus 5 and divide it by 2, and that's going to be 7 over 2, or 3.5. So the middle of the x's is just the x coordinates added and divided by 2. The middle of the y's are going to be the y values added up and divided by 2. So the midpoint will be at the point 3 over 3 for x, and then up 3.5. So this is my midpoint. And that makes sense. I mean, it's halfway between those two ordered pairs. So, we've got those that aren't graphed, and you can find the midpoint nonetheless by using the same formula. Well, you just take the two x coordinates and you plus them. So -2 plus 4 and divide by 2, that's 2 over 2, which is 1. That's the x coordinate of your vertex. You take the x's and add them up and divide by 2. To find the y coordinate, well, you take the y values, 3 plus 0 and divide by 2, and that's going to be 1.5. That's 3 over 2, which is 1.5. And so the midpoint would be 1 and 1.5. That's the ordered pair that's going to be halfway between those. So if you graph those, you notice that point would be directly in line with the other 2 points. Now let's look at the last one. If you want to pause the video and try it yourself, you're welcome to, but you add these up. So you can take -8 plus -2 and divide by 2. That's -10 over 2, which is -5. Okay. And then you take the y values, which are going to be 3 plus 7. So 3 plus 7 and divide by 2. That's 10 over 2, which is 5. So the midpoint between those 2 points given is going to be -5, 5. So midpoint is pretty straightforward. Add up the x values and divide by 2. Add up the y values and divide by 2. If you're just working with a coordinate plane, we just add up the 2 coordinates, the 2 x values, and divide by 2. Okay, or the 2 locations. So looking at page 2 or the back side, we're going to apply this a little bit. We're going to talk about, okay, what happens if they, they give you a scenario where they're like, okay, here's x, y, and I'm going to give you m. Point M is going to be halfway between those. And if they tell you, say, x is, say, 2, 7, and instead of giving the other endpoint and having you find the middle by adding the x's and dividing by 2 and adding the y's and dividing by 2, they instead give you the midpoint, the halfway point. They're like, hey, start at 2, 7, go to 6, 1. What would be your endpoint if you keep trucking in that direction? So we can kind of visualize this if we graph it on a number line. So you're like, okay, if you start at 2, 7, that's x, and you go to 6, 1, okay, and that's m. If you can think, like, if you're headed from x, down to m, and you're halfway there, well, then keep on trucking in that direction. Your y value is going to be down here, isn't it? Okay, if the midpoint is like halfway point, it's going to be roughly down there. Now, you can kind of, look on your graph and kind of count and see where it's going to exactly be, and that's an option. But I also want you to know it kind of like using patterns. So if you look at the x's and say, halfway point, you got to see the pattern. So if you look at the x's, so it goes from 2 to 6 on the x's. What did we do when we went from 2 to 6? Well, if you look at that, you would notice you're going from 2 to 6. You plussed 4, didn't you? Okay. So to get to the end result, you just do it again. It's kind of like leapfrog. You did it one time to get halfway there. You're going to plus 4 to the x value again. And oh, wait, that'll give us 10 for our x coordinate. So again, we're following the pattern. Say halfway there, you got from 2 to 6. I plus 4 to the x. And then I'm going to do it again. I'm going to get to 10. And so then you look at the patterns for the y values. Well, for the y values, you went from 7 to 1 by, it looks like you minus 6. We'll do it again. Okay, that's how you get to the endpoint. So it's 2 leaps. So you minus 6 to get to here. Now let's minus 6 again. And then you will get 1 minus 6 is going to be -5. So your value would be 10, -5. And if you plot that point, go right 10 and down 5, 1, 2, 3, 4, 5. It's going to be right here. That's where y actually is. So I kind of guesstimated it, but that's going to be where y is. And it makes sense. On the way towards y, halfway point would be m, and when you keep on trucking, you get to y. And so that's kind of what we're looking to do. You can try it again on the problem below it and say, all right, if they don't give you the endpoints, but they do give you kind of a scenario and say, okay, S is the midpoint. And so you start with R and go to T. And if you start with R is -6, -1, and S is going to be -1 and then 1. Okay, let's look at the pattern. How do you get here? If the halfway point is going to be -1, 1, what did you do to get there? Okay, so to get from here to here, it looks like you plus 5. From -6 to 1, you plus 5. Do it again. Okay, so if you plus 5 again, you're going to get to 4. Okay, and they say, okay, so I kind of following the pattern, what am I doing? And then look at the bottom. From -1 up to 1, I plus 2. We'll do it again. Okay, so plus 2. You can look at a number line and be like, if I started at -1 and moved to 1, I moved to the right 2. We'll do it again. You plus 2, and you get to 3. So your answer for the endpoint is 4, 3. And so you're following the pattern for X. Continue it one more time. It was really fun. Do it again. And then same with the Y's. It was really fun. Do that pattern one more time. Okay, bisectors. Okay, so for bisectors, bisectors mean it chops the segment into two congruent pieces. And so you can have a segment or a line or a plane or a point that bisect a segment into two pieces. Those are like a little knife that chops it in half. Okay, so a bisector is a chopper. And so in this case, notice a point chops the line in half. And so a bisector chops this point in half into two congruent pieces. So you can add up the two pieces to equal the total, but we don't know the total. Okay, but we do know that the two pieces are congruent because we have a bisector. We've got a midpoint. And so therefore, we can set the two segments equal to each other. Okay, and solve it. -5y from both sides. You get 4y minus 2 equals 14. So plus 2 to both sides. You get 4y is equal to 16. Divide by 4. Y is equal to 4. Okay, so we're most of the way done. Now, of course, they're like, hey, how about you just find PQ? Well, PQ is right here, and that's this expression right there. So if you take PQ, you take 9 times y, and you minus 2. I don't know, I'm using a highlighter, but I'll switch to pen. So you do 9 times 4, and then you subtract 2. That's 36 minus 2. That's 34 units. Okay, if they give you inches or centimeters, you would do that. So an option is if you've got a bisector, the segments are going to be congruent, so you can set them equal if you know both sides. Okay. The next thing is, if they tell you have a midpoint, again, let's draw it. So you've got a segment, and you've got A goes to B, and M is halfway between it. So those are congruent. This is 3x. They also tell you that AB is going to be 5x plus 10. Okay, you're allowed to add the two pieces up together to equal the whole. So add up some of the parts equals the whole. Well, I don't know MB, except that I do. Okay, AM and MB are congruent because M is a midpoint of AB. So if AM is 3x, well, then that means that MB has to be 3x as well. And so we're allowed to take 3x plus 3x again to equal the 5x plus 10. The sum of the parts equals the whole. So 6x equals 5x plus 10. And minus 5x from both sides. You get x is equal to 10. And then that's your first answer, but then they want you to find out the measure of AB. So go to AB, which is this expression here, and it says to get AB, you do 5 times x plus 10. So 5 times 10, and then plus 10 again. That's 60 when you take 50 plus 10, so that's 60 units. Okay. The last question we didn't get to in class, it's very similar to the ones that you've already done. D is the midpoint between those two values. And so here's D in the middle, and then it's B of EF. They tell you ED is 4x plus 6. They tell you that DF is 7x minus 9. Well, I guess since they're midpoints, we can set them equal. So 4x plus 6 equals 7x minus 9. Subtract 4x from both sides. Get 6 is equal to 3x minus 9. Let's plus 9 to both sides. You get 15 equals 3x. So x is equal to 5. And then ED, well, if we plug this into this expression right here, oh dear, here we go. My pen stopped working. You got 4x plus 6, we got ED, which is this part right here. If x is 5, so you do 4 times 5, and you add 6, that's 20 plus 6, or 26 units. Okay, so the moral of the story is that midpoints divide a segment into two pieces that are congruent. You can find the midpoint by adding the two x's and divided by 2, and adding the two y's and divided by 2. You can find the midpoint of a number line by adding up the two endpoints of the segments on that line and then dividing by 2. We can learn a little vocabulary today. Thank you.